Hi everyone, welcome to a lesson on multiplying and dividing rational expressions. This lesson is numbered 1.5, but it might look different in your package. Either way, this is a lesson on multiplying and dividing rational expressions. Two things you're going to learn this lesson. One is learning how to define a rational expression. And the second thing is how to simplify rational expressions. Okay, so I'm going to give you a rational expression and I'm basically going to ask you to do the operation, which is either multiplying or dividing. So in order to do that, let's recall some operations with fractions. So when we multiply fractions, all we do is we multiply the numerators together and we multiply the denominators together. Now, sometimes we're able to cross-reduce in order to make things easy for ourselves. For example, I can actually reduce 10 over 12 and I can reduce 24 over 25. But the way I'm going to do that is I'm actually going to cross-reduce. Cross-reduce refers to when I cross out a numerator and denominator in different multiplied fractions. So in this case, I can see that 5 divides both of these evenly. And then I can have a look at the 12 and the 24, and I can also cross-reduce those. And I can see that the 24 and the 12 are both divisible by 12. So when I rewrite this fraction, it becomes a lot easier to multiply. And remember, I just multiply the numerators together and I multiply the denominators together. Okay, I do not need a common denominator when I multiply or divide fractions. That's only for addition and subtraction. How do I divide fractions? So if you recall, what you actually do is you take the numerator, okay, and you just copy and paste it, and what you're going to actually do is multiply by the reciprocal of the denominator. Okay, and we can see here that there's some cross-reducing that we can do. So this actually becomes 3 over 4 times 1 over 1, which is just 3 over 4. And if I got an answer that I could reduce, I should be reducing. Okay, what is a rational expression? It's actually really simple. It's just when you divide two polynomials. So the thing that's special about a rational expression is that it has a denominator. Okay, and that the denominator is never 0 and the denominator is a polynomial. So let's take a look at example 1, and we can see that here we're multiplying two rational expressions. I have a fraction multiplied by a fraction, and I'm going to simplify this by canceling and cross-reducing terms. So canceling refers to things like this, where I cancel within a term. So I can see that the x variables cancel out there. I can also see that there are 3 y's in the numerator and 4 y's in the denominator. So I can reduce that, so it just becomes 1y. Similarly here, I have 2 x's in the numerator and 1 in the denominator, so I can just rewrite this as 6x over 5y times 15 over 8y. Now I can see that there is actually some cross-reducing I can do. So this is called canceling when it's within a fraction. Cross-reducing happens when you cross out things between numerators and denominators of fractions that are multiplied together. So we can clean this up. So we've got 6x over y times 3 over 8y. And now that it's all nice and simplified, actually I did miss one, didn't I? But it'll come out in the wash here. Okay, so 8y squared. I can see that I can actually further reduce the 8 and the 18 by dividing both of them by 2. So this here is my final answer, 9x over 4y squared. So we're about to get into some more complicated rational expressions, but before I do that, I wanted to show you a common mistake. So a common mistake that happens all the time is when guys see a rational expression like this And they tell me that they can cancel the x in the numerator with the x in the denominator. That is not actually how it works. So let me give you an example of something. So let's say I have 49x minus 14 all divided by 28. Okay, so what I can recognize here is that I can actually reduce this because all three of these things are divisible by 7. So this becomes 7, this becomes 2, and this becomes 4. Now, the reason it doesn't work here is because what we're doing when we slash out these numbers with my red pen, what we're actually doing is if I start with actually 49x minus 14 divided by 28, what I'm actually doing is factoring out a GCF in the top, and I'm factoring the same number out of the bottom, and I'm canceling these two 7s. Okay, so that's the reason why when I get something like x squared plus 4 over x, I can't just cancel out the x's because there's no x in this term here, 4. So there's nothing I can do, okay? No simplification can be done here. So just really beware of that because guys tend to do that a lot. Like for example, if I tell them to simplify this, they'll just start slashing out the a's and the b's, but you can't do that, okay? You can only do that if they appear in all the terms. Okay, so let's get started and let's do this properly. So what can we do here? Okay, so there's a lot going on there, but I think I have a over 3d times 4c squared over 2. And now I can actually reduce even more. Okay. So I could have just multiplied these all together. It would have been a huge number and then I would reduce later. So the cross reducing actually is helpful before I get that. I get really big numbers. Okay, so how does number 2 work? So the first thing you need to know is that when I have fractions like this, okay, what's here that you actually can see is something called implied brackets. So there are implied brackets that glue together the numerators and denominators of these rational expressions. Okay, so when I go to simplify something like this, I don't have to write them in, but I know they're there. Okay, so I can see that in the denominator here, I can actually factor out a 2. And I get a minus 3. So remembering that there are implied brackets here, I can actually cancel the a minus 3 here in the numerator with the a minus 3 in that denominator. So I'm going to rewrite this as b minus 3 over 2b plus 3. Now some guys want to expand that. I would just leave it alone. It's a lot neater and it's a lot easier for me to mark if the denominator stays factored. Okay, so let's just keep the denominator factored when we can. Okay, let's do number 3. And what we'll see here is in the first fraction, I can't really do too much, but in the second fraction, I can factor out a 2, but I can also factor out a negative from this denominator, and we know that trick. Okay, that when I factor out a negative, I just flip the terms and I keep a negative in between them. So I can actually see that the 3a minus 2b's cancel out and the 2a plus 1 cancels out. So I end up getting 2, negative 2. Okay, so now we're getting into more interesting ones with number 4. So what we want to do is we want to factor all numerators and denominators. Numerators and denoms, so that we can see if there's anything we can cancel. Well, this numerator I can't do much about, but now if I look at the denominator, 2x squared, so I'm going to write it up here, 2x squared plus 9x plus 4. Well, I know how to factor this. I multiply the 2 times 4, the 8 times c value together, I get 8. And then I write out the factor pairs of 8 that actually help me break up this middle term 9x. And I actually got it in my first go here. 2x squared plus x plus 8x plus 4. And I got the x and the 8 from these two numbers. And now I'm going to use grouping. 2x plus 1 plus 4, 2x plus 1. So I know that this thing actually factors to 2x plus 1, x plus 4. So I kind of like that when you do your scratch work somewhere else, okay? And then you actually put the factored form back into the main line of the question. So now we're going to factor this numerator, and I can see I can factor out negative 5y. And I'm going to end up with 2x plus 1. And in the denominator, I can see this is in the form of x squared plus bx plus c. So I need two numbers that multiply to negative 6 and add to negative 1. So these ones you should be really fast at by now. Okay, and remembering that there are implied brackets here, I can now go and cancel. Okay, and let's see what we have left. Negative 5y over x plus 4, x plus 2. Okay, guys, so what I encourage you to do, so remember the name of the game here is to factor all numerators and denominators and then cancel out terms. Okay, so basically this is the recipe for these questions. Okay. The only thing I can really change is what things you need to factor. So if you look at number 5, you can see that you're going to factor numerators and denominators. So what I encourage you guys to do right now is pause the video, try 5 and 6, and then start it up again when you want to see my answer. Okay, so pause it now, give it a shot, and then come back when you're done. Okay guys, so for this last one, what we're gonna do is with the division, okay, we're gonna multiply by the reciprocal. So I'm gonna do a couple of things at once here. I'm gonna factor the numerator here. So I need two numbers that multiply to negative 2 that add to positive 1. So I do believe that's x plus 2y, x minus y. And then I need two numbers, 2x squared plus 3xy plus y squared. So remember, we can just, if we want to simplify things, we can just remove the y's and just look at it like this. So either way, we need two numbers, okay, that are going to multiply to a times c, which is 2. And I know that my factor pair that I'm going to use is 1 and 2. So I've got, let's go back to the original question. So it's 2x squared, 3xy plus y squared. I'm going to break up that middle term into 2xy plus xy plus y squared. And then I'm going to group and factor out the GCF in both of them. oops. And I know I've done something right because these two are the same. So I'm going to factor out the x plus y, 2x plus y. Okay, so this is my scratch work. I'm just going to move it over a bit for this denominator. So that's x plus y, 2x plus y. And then what I want to do is I want to multiply by the reciprocal. Okay, so I'm going to flip this over. So my denominator is going to be x plus 2y. And then my numerator, so let's factor 2x squared minus xy minus y squared. So if I look at the coefficients here, I know that a times c is -2. And I know that I need to break up my middle term of -1 here. So that's going to be -2 times 1. 2x squared minus 2xy plus xy minus y squared. So here we go, we've got x minus y, 2x plus y. So we can see that rational expressions are a great review of factoring of all kinds. Okay, oh, that one actually doesn't cancel. So I've got 2x plus y, x plus 2y. All right, so I am left with x minus y over x plus y. And just to be sure, we might as well check it down here. So I actually put both forms of the solution. So you can leave the numerator in factored form, or if you want, you can distribute it. I'd rather you just not do an extra step. You could probably just end right here, but let's just do it in case you'd prefer to expand. Okay, so both of these two answers here, these two are exactly the same. Okay, so either one will suffice as the answer. Okay, so a nice review of factoring, and you've got the gist of how to multiply and divide rational expressions. Okay, guys, make sure you're looking at the homework, and let me